Here's the solution for day one. Solve the equation. So in question A, we have 2 times the cosine of x plus 1 equals 0. First step, subtract the 1 from both sides, and that would create 2 cosine x is equal to -1. Then divide by the 2 on both sides, creating cosine of x is equal to -1/2. Now that we've isolated the cosine function, we want to remove cosine by doing its inverse. When you take the inverse cosine, it will make x equals the inverse cosine of -1/2. At this point, we want to look up on the unit circle what value of x has a cosine value of -1/2. The angle for that is 2 pi over 3. But a 2 pi over 3 angle is not the only angle that has a cosine value of -1/2. On the unit circle, I see that the angle 4 pi over 3 has a cosine value of -1/2. So we want to include that. However, we're still not finished because the cosine function is periodic. If you add 2 pi to either of these values, you would be back at an angle that has a cosine value of -1/2. For that matter, you could add 4 pi or 6 pi. You could even subtract 2 pi or subtract 4 pi. We need to indicate all answers that work for x. The way that we're going to show that is to take these answers and modify them. 2 pi over 3 plus 2 pi times k, where k is any integer. If k is a positive integer like 1 or 2 or 3, that would create positive angles that point to the same spot as 2 pi over 3 does on the unit circle. If k was a negative integer like -1 or -2 or -3, then that would create negative angles that are at that same location. Now I'm going to write the word or and do a similar thing with this angle here. 4 pi over 3 plus 2 pi times k. By using the variable k to represent all integers, these algebra expressions show all of the angles on the unit circle that have a cosine value of -1/2. You don't have to pick the letter k to be the symbol that represents that integer either. You could choose an n or some other letter. And you don't have to put the k at the end of the 2 pi. You could put the k like right in here and say 2k pi. It means the exact same thing. Now question B, let's solve this one first by adding 2 to both sides. So this makes cosecant squared x is equal to 2. Now do the square root. So we get cosecant of x is equal to positive or negative square root of 2. When solving for x, we know that we're going to do an inverse. But inverse cosecant is not something we're as familiar with doing as like an inverse sine or inverse cosine. In fact, if this ends up being something that we need to do on the calculator, then there's not even an inverse cosecant button on the calculator. So in the next step, let's rewrite this using the sine function. The sine of x is equal to the reciprocal of this, which is 1 over plus or minus the square root of 2. Now let's rationalize this. This makes the square root of 2 all over 2. Now we can do inverse sine to remove the word sine and get the x alone. So we're going to have x equals the inverse sine of positive or negative square root of 2 over 2. Let's think about what this means. We're going to look on the unit circle, and we're going to find all of the angles that have a sine value of positive square root of 2 or negative square root of 2. There are going to be 4 of those on our unit circle. They occur at pi over 4, 3 pi over 4, 5 pi over 4, and at 7 pi over 4. These first 2 angles have a y-coordinate of positive square root of 2 over 2, whereas these 2 angles have y-coordinates of negative square root of 2 over 2. However, it's not only these 4 angles that would have a sine value corresponding to this fraction. Because the sine function is periodic, if you add or subtract multiples of 2 pi to all of these answers, that will take you back to that same point around the outside of the unit circle. So let's show that with an algebraic expression that involves the letter k. Here's how I'm going to write that. The answer for x is pi over 4 plus pi over 2 times k, where k is representing any positive or negative integer. This single expression will account for all 4 of these angles plus all of those angles plus or minus multiples of 2k. Think it through. If k was positive 1, then this would be pi over 4 plus 2 pi over 4, which is 3 pi over 4, this angle right here. If k was positive 2, then this would be pi over 4 plus 4 pi over 4, which is 5 pi over 4, this angle right here. If k was positive 3, this would be pi over 4 plus 6 pi over 4, which is 7 pi over 4, and that's this angle right here. If k was positive 4, this would be pi over 4 plus 2 pi, and that would be the angle created from starting with this and adding 2 pi.